trying to figure out the number that goes in this box right here. And you probably saw this in class. You might have even been given a formula. Any of that sound familiar? Anything come to mind?
Yeah.
So there's this number right here is called b. And that comes from the ax squared plus bx plus c. So the number that goes in here, in this box here, okay, it's got a formula for it. Now, when there's one here on the outside, it's fairly straightforward. You take b, you divide it by 2, and then square it. Did you see that in class?
Yeah.
Okay. So you're going to take 4, cut it in half, divide by 2, that's 2, and then square it, so that becomes 4. Is that okay?
Yeah.
So they sometimes will emphasize the formulas. I don't emphasize them that much because I think there's a better way to do this, but this is what we've got. So in the second problem, your b is minus 16. So it does take on the sign. That sign goes with it. All right, so you're going to take your b value, divide it by 2, and then square it. And the order does matter. You really got to do it in the right order here. Divide by 2, and then square. What would that become?
64.
64. Very good. Any questions on that?
No, it's pretty straightforward.
Yeah, I like hearing that. It really is. It really is. It's not meant to be difficult, but it, yeah, could be. Now this one's a little bit harder because your b value is 7, and 7 is not an even number. So when you divide it by 2, you can't really divide it by 2 because it's a decimal. So you kind of can, but you kind of can't. Like it doesn't work out like a whole number, which is what we're used to.
Yeah.
So here's what you do when you square it. You have to actually square the top number and square the bottom number. So what is the top become? What's the numerator?
49. And then over 4.
Good. Very good. Any questions on that before we move on to 4?
No.
Okay. I don't hear a lot of excitement from you, but is this just awful? I mean, is this just uninteresting? Because it's not great for me either, just in full disclosure. Like this is not the most interesting math topic in the world.
Yeah, not interesting very much.
Yeah, it's like what we're doing is like we're solving problems in the same way that you would like ride a bus when you have a car to drive, or maybe even worse than that, you know, riding a bicycle when you have a car and you've got a long journey. We're taking the long way around. Now there are some benefits, just like there are benefits to other things, but you're truly only doing this for this part of the course. You know, you won't see this again until next year.
Okay.
All right, so we're going to do the same thing here, but this time, and I really actually like the way they've done this. I'm gonna put it in red here. So what they're trying to show you is that whatever number you put here, you're going to put the same number here. So it's just like the previous problems. What is your b value in this problem here?
6.
6. So you're going to take 6 divided by 2 and then square it. What is the result of that?
9.
Okay, so it's going to be 9 and then 9. Okay, and the idea is like whatever you do to one side of the equation, you have to do to the other. And you know, it's kind of a sharing thing. It's like, let's say, I don't know if you have any brothers or sisters, I can't recall, but it's like if you get 9 pieces of candy, they get 9 pieces of candy or something like that. It's got to be fair. Any questions on that so far?
No.
All right. So now I'm going to rewrite just the left side. The left side is a perfect square trinomial. And I looked back because I was actually helping another student with some of this, and I used some of the problems that we had been working on. We've been doing this for like almost a month. So the idea is that you're now like an expert at perfect square trinomials. Okay. Now I'll assist here if needed, but do you remember how to factor perfect square trinomials?
Multiple different ways to do it.
That's correct.
You gotta find the greatest common factor, or in this case.
So it's the first way is two numbers that multiply to 9 but add up to 6.
Yeah.
And that's 3 and 3. But what do you notice about those two numbers?
They're the same.
They're the same. So it's like, well, maybe there was a better way. You can take the square root of the last number. And it becomes x plus 3 squared. Do you remember us doing that?
Yeah.
Okay. Now the reason it's plus is because of this plus right here before the 6x. That's what maps down. Equals, what is minus 8 plus 9?
1.
1. Okay. So we are done completing the square, just to be clear. Like we have absolutely done completing the square, but now you have to solve using the square root method. And if you're not sure what I mean by that, I will show you here. Do you know what I mean by the square root method or not?
I don't think I do.
Okay, so maybe when you see it, you'll say, oh yeah, I said that in class. So you take a square root of both sides, but on the side with the number, it's plus or minus square root. So that's really key. On the side with the number, it's plus or minus square root.
I think I remember that. Something kind of familiar.
Now on the left, the square root undoes the square, meaning that the only thing left over is the x plus 3, and you don't show it in parentheses. You just completely leave it out. Equals, what is the square root of 1?
1.
Okay. So then now this is where it becomes two problems. Sometimes it's referred to as case 1, case 2. X plus 3 equals 1, x plus 3 equals minus 1. Do you see how the left sides are the same in both?
Yeah.
Okay, so now you solve by subtracting 3 from both sides. Can you tell me the final answers here?
Sure. That'd be minus 2 plus 2.
Minus 4.
No.
Minus
Yeah,
4.
minus 4.
So it's not necessarily like opposite sign answers. Any questions on that? What we've done here? We're going to do more, but just.
No.
Okay. So again, we start out by completing the square, just reviewing here. You got to complete the square. Then you have to do a perfect square trinomial factoring. Then you take the square root of both sides. Then you split it apart. So, in truth, this problem requires you to do like a bunch of things. Give me just 30 seconds here. I'll be right back. All right, thank you. So we're going to do another problem. We're going to work it through together. Yeah, there's just like 3 or 4 things now. It's not just, oh, here's, one thing. So we're going to first figure out what goes in the box. So that's like thing 1. So what goes in the box is b divided by 2 squared. So what is the b value in this problem?
-2.
-2. So we're going to divide that by 2 and then square it. Can you tell me what that becomes?
Would it just be 1?
Yeah.
Or -1.
Yep. Well, let's be careful here. -2 divided by 2 is -1. Okay. So it's -1 squared, and that means -1 times -1.
Oh yeah, I keep forgetting that.
Very, very important. You don't want to crash the spaceship with the wrong sign here. So it's +1. Now it's not always positive, but for now you can think it's always positive. All right. So now just focus on the left, and I'm going to rewrite it here. X squared minus 2x plus 1. This is a perfect square trinomial. Okay. Now, 2 numbers that multiply to 1 but add to -2. Any idea what that is?
-1.
Yes, perfect. Okay, equals 15 plus 1 is 16. Okay. So do you remember what we do at this step here? I know it's a lot to keep remembering, but you take the square root of both sides. On the right, it's plus or minus. Plus or minus.
Yeah.
Okay, so on the left, it undoes the square. On the right, it's plus or minus 4. And this is the whole case 1, case 2. X minus 1 equals 4. X minus 1 equals -4. Can you give me the 2 answers from here, please?
Sure. I got 5 and -3.
Very good. So I want you to just talk me through this problem. Just try to, as best you can, in your own words, so I can gauge how much you do or don't understand here. Tell me what we did to start out in as much detail as you want.
Okay, so you find the b value, and then you divide it by 2, and then square it, and whatever the answer is, which is that 1.
Good.
And then on the left, there is the perfect square trinomial.
Okay.
And then you find 2 numbers that add or multiply to 1 and add up to -2, which was just -1. And then you take the equation and you square it,
Square
Then-
root, square root.
Yeah, square root.
Why is it plus or minus?
Because I forget.
So I actually didn't tell you why. I just said that it always is plus or minus. And that's where you've got to decide if you really want to like know and you don't need to know, or if you're just like, yep, I know to always do this, but I don't know why, but I'm just going to do it. So if you want more explanation, I can give you it. I'm suggesting not to, but that is up and there. What do you do from here?
You trying to find the word, but you do x minus 1 equals 4, and then x minus 1 equals -4 because it's the 2. It's the plus or minus.
Yeah,
And then you
very good.
solve it.
Very good. That was great. I mean, you like, and I don't know if you ever do that when you're studying, but just saying stuff out loud is a great way to see if you like got it. Now, I want to show you something really important here. What was the B value in problem 4?
6,
And what number went in parentheses down here?
3.
So how do you go from 6 to 3?
Yeah, divide by 2.
Okay, now let's look at this problem here. What is the value of B?
-2.
Now what number went here?
-1.
Is it the same rule? Do you divide this by 2 to get that?
Yeah.
Yes, you do. Okay, let's look at another one here. All right, I want you to find the number that goes in the box here for us, please.
All right. Uh, 4.
Okay, and then this other box is also 4. So on the left here, I want you to tell me what this factors into, please.
Okay. X plus 2 squared equals
Why is it 16?
yeah. Oh yeah. Because it took me a second to
Good.
to find on the paper where I had written it down.
Okay. What do we do from here?
Find the square root of each thing.
Okay, and plus or minus, and kind of assumed, which is dangerous. Do you want me to give you any more explanation for why it's plus or minus? It's not a test or anything. I'm just asking. Yeah.
No.
Okay. All right. So this becomes x plus 2 equals what? What's on the right here?
4.
Plus or minus 4.
Oh yeah.
Very important. Very, very important. It's both. because you have two answers. You always have two answers to these things. So it's x plus 2 equals 4, x plus 2 equals minus 4. Again, notice I'm writing the same thing on the left. One's positive, one's negative.
So it's x equals 2 and x equals minus 6.
Yes. How does this compare to sort of previous problems you've done? Or is this maybe the longest type of problem you've done in math in a while?
Yeah.
So you probably get like 1 on a test. It'll say like, thou shall use completing the square to solve this. And you have to know how to do it for that reason alone. I was working with a student today that, he said, well, I hope it's not on the test. And I always think you probably heard me say, it's like, well, no, you should know how to do it. And then you hope it's on the test because you know how to do it. Try to assume this will be there. All right, let's look at 7 here. Can you tell me what goes in the box, please?
Sure. Six before.
Okay. Now what happens? I know we normally focus on the left, but what happens on the right here?
It would cancel out.
Yeah, and that does happen, although this would not be an exam question, by the way, but it does happen from time to time. So can you factor the one on the left for me, please? Tell me what that becomes.
X plus 8.
Okay. What is the next step here? What have we always done? Forget about the fact that that's 0 here, but what do we do on the left and the right from here?
Do the square root thing.
Yeah.
Plus or minus.
Yeah, now this is, of course, math's full of exceptions. There is no positive or negative 0. It's just 0. So this time it becomes 0.
Okay.
On the left, it's x plus 8. And so you might say, well, hey, Matthew, I thought you said that these always have 2 solutions. And sort of right, sort of not. If we go over to where 8 is, let's just say that's 8 because we're going by 2. This actually hits the curve or hits the intercept there, so it touches, and that's considered a double root, except I've got this on the wrong side. So let me fix that here. It's one of the advantages of the digital ink here. Okay, so it still works. Just when you get 0, there's only going to be one solution with that. Any questions on that?
No.
Okay, so you might feel like, hey, I've got it, and I could certainly see why. But this is the format that the problem will take. So up until now, they've really been stepping you through how to do this on your own. But this is what a real problem would look like. So here's step 1. We're going to move the constant to the other side of the equation. X squared minus 2x equals 35. Okay. And now I'm going to draw in the same box that you've been that's been there for you. So does it look like now like a problem that you've been doing?
Yeah.
Okay. I'd like you to try it from here. Ask me any questions you want, check any steps you want. It is plus and plus, like you're gonna have a number in here, but just a chance to see where you're at on this.
All right. X equals 7, then X equals -5.
Yeah, that's actually perfect. So, if you're wondering, well, how does he know that's that fast? And it's not about me. It's actually just this one actually factors into X minus 7, X plus 5. Okay. And so you're right. It's X equals 7, X equals minus 5. Now you're not supposed to factor this. You are supposed to do it by completing the square. But sometimes you can check your answer using another method. That way you know if your answer is correct. Does that make sense?
Yeah.
Okay. All right. So new problem here for us to look at. You have to use completing the square here. All right. Now this one's awkward because, excuse me, because it's already a perfect square trinomial. And so what I might ask as a student, say, hey, Mr. Teacher, Mrs. Teacher, when I looked at this problem for homework, I noticed that it's already a perfect square trinomial. Can I just factor it? Or do you have to do the thing we did in the last problem, which is move the 100 to the other side of the equation, and then fill in the boxes? Okay. Now, when we fill in the boxes, it's half of this number, 20, half of this number squared. What is half of 20?
10,
And then 10 squared is?
100.
So what's weird about this is why I'm suggesting this, is because we're now back to where we started. You see that?
Oh, yeah.
It's like making four right turns. You get right back where you started. So I don't know. I mean, that's maybe a question to ask. Would your teacher be receptive to something like that?
Probably.
Also might show them that you're kind of engaged in the problems. Like, hey, I was, all the other ones I noticed that I had to move the number over, but this one, like I could just factor it. Like, and I noticed when I did the perfect square stuff, it ends up being exactly the same. It ends up being x plus 10, squared equals 0. Okay. So nevertheless, anyway, you've got to be able to solve this last line here. So can you do that for us?
Sure. X equals minus 10.
You got it. All right, so let's look at 10 together. 10 together here. Actually, let me have you do 11. We'll do 10 now. We'll just do them in order. There's no benefit here. All right, so first thing you're going to do here is you're going to move the minus 7 to the other side of the equation. So plus 7, plus 7. So x squared minus 4x, leave a space, equals 7. So you gotta, like, I think students mostly forget to leave the space. So just be very careful there here. Can you tell me what goes in the box?
Sure. One.
Say that again.
One
How did you come up with 1?
is, wait. Oh, no, it's 2.
How did you come up with 2?
Wait. 1 sec. It's 4.
Yes. So plus 4, plus 4. Now on the left, I want you to factor the perfect square trinomial and tell me what the result is, please.
X minus 2 equals 11.
Great. Now this is the first time. This is the first time that we cannot take the square root perfectly of the right-hand side. Like there is no perfect square root of 11. Do you agree with that?
Yeah.
Right. So what do we do? Well, you don't do anything. You just leave it as the square root of 11. All right. Now you will think, well, how am I going to solve this? You do exactly what you've been doing. You set it equal to positive square root 11 and x minus 2 equals negative square root of 11. And from here, you add 2 to both sides of the equation. X equals 2, but it's plus square root of 11, add 2. X equals 2 minus the square root of 11. So what some students, and this is another, question for your teacher. Some students just go to this line right here, this x minus 2 equals plus or minus the square root of 11. And they actually do the following. They add 2 to both sides, but they sneak that 2 in front of the plus or minus. So they write their answer as 2 plus or minus square root of 11. A good question to ask your teacher is can I do option 1? Because I think that's what they will be okay. Or do I have to do option 2?
All right.
Any questions on that? We're going to do another one like it.
No questions.
Okay. We're going to go to 15 next, because 11 works out nice and it's kind of different. But it's like the one we just did. So that's why I want to do it. So it's kind of a, similar guided example for you. What should I do first here? What have we done in all the other problems?
We would do minus 13 on both sides.
Yes. So it'd be x squared minus 8x equals minus 13. I would continue to put those boxes there. Can you tell me what goes in the box?
Sure. $16.
Okay, so positive 16, positive 16. The left side becomes x squared minus 8x plus 16 equals 3. Can you tell me what to do next from here?
Sure. Gotta find a number that multiplies the 16 but adds up to -8.
There's also a shortcut here, and it has to do with the b value. Do you remember that? We said it earlier. So let's look at the previous one. How does this number minus 2 relate to minus 4?
Oh, it's divided by 2.
Yes, it's always b divided by 2.
So it'd be 4 or negative 4.
X minus 4 squared equals 3. What is the next thing to do from here?
Find the square root.
Yes. Now, what do we do on the right? That's what I'm mostly interested in. Tell me what to write on this to the right of the equal sign.
Positive or negative square root of 3.
Good. Very good. And then for now, I'm just going to assume that we're going to add the 4 and we're going to push it right in front. So x equals 4 plus or minus the square root of 3. Is that okay?
Yeah.
Why don't you try 12 on your own? Ask me any questions you want along the way. Obviously, we're not gonna get through all of this, but I know you didn't send everything, so maybe you still got some time on this. This is most like the ones we've been doing. How are you doing on this one?
Pretty good.
There is no square root of 39, so you can, if that was a question.
Okay, so I got x minus 7 plus square root of 39 and x plus or x equals.
Does it look like what I've written down? Because you said it
Yeah.
kind of okay, perfect. That's really good. That is super good here. Okay, so with the limited time that we have remaining here, I guess I want to share some thoughts about some of the problems that you have left. Do you have to get this done for tomorrow?
Yeah.
Okay. We've skipped some of the awkward ones here. This one ends up being a fraction, which is no good. So it ends up being x plus 3/2 squared, and you end up adding 9/4 to both sides. So that's kind of the hint for that one. And then we did not do 13, did we?
No.
Okay, so I'll give you a hint here for 13. Wow, there's a lot for them to ask you to do. So here you have to move the 6x back over. And you've got to fill in the box here on both sides. So this ends up being +9 +9, and then it's like the ones we've been doing. 14 is x squared minus 10x. So here's your box, here's your box. So it ends up being plus 25 plus 25. So you can see it ends up equaling 0. All right. And then 15 is probably the last one I can comment on. Or no, we just did 15, didn't we? We did. Yeah, we already did it. Okay. I hope that helps there. I know it's kind of rushed there at the end, but that'll maybe give you enough to be able to do it. We can certainly pick up here on Thursday and do more. There's